Hello everyone, welcome back to Cloud for All YouTube channel. In today's video, we are going to explore a really interesting and powerful topic in data structures, that is graphs in Python. And we will be exploring with examples. We will look into adjacency list versus matrix, and we will finally cover real world applications for graphs in Python. So graphs are super useful in the real world, from Google Maps to social networks like Instagram or Facebook, from computer networks to web crawlers. Graphs are everywhere. By the end of this video, you will know what is a graph and the types of graph, how to represent graphs in Python using coding, and where graphs are used in real life. Let's deep dive into the topic right now. First of all, what is a graph? What is a graph? Graph is a collection of nodes, also called as vertices, and graph has edges apart from nodes, which are the connections or links between nodes. For example, map that has cities as nodes and roads as edges. So the cities will be linked with edges. And another example for graph is social media. Users are the nodes and their friendship is edge, which is the link between each user. Graphs also help represent relationship between things, not only persons. So let's move to next section. We have already seen what is a graph. It is a collection of nodes that is also called as vertices, and edges that is linked to next node. And graph represents relationship between items. It can be users, it can be, for example, cities or any object. So what are the types of graphs? There are four major types of graphs. First one, undirected graph. So that is to connect, go both ways. Like if we have object A, object B in the graph, so the direction will be from A to B and B to A. It is both the ways. So for example, in Facebook, the relationship is between two users. It is from user A to B and B to A as well. So it is bidirectional. So which is called as undirected graph. And the second one, directed graph, which is specifically for one-way connection. For example, Instagram following. A user can follow any Instagram account and it doesn't need to be followed back, which is directed graph example. And the third type is Weighted type graph that has edges have values like cost. So node has a edge that it has a value which is also cost. So distance also another value that edge can have as part of weighted graph. And unweighted graph is fourth type of graph. It just shows connections without the cost or distance as value to edges. That's about types of graph. Let's discuss about further in next video. Let's now move on to what is types of graph representation. Number one, adjacency matrix. So the sample adjacency matrix looks like this in Python. Zeros and ones. So this is very easy to implement. So the graphs can be represented as a adjacency matrix like this, and this is very easy to implement. And there is one backdrop with this adjacency matrix, that is it takes more space as shown in this example. So to talk about more, dictionary where keys are nodes. So in previous example we had zeros and ones. So which is nothing but a dictionary form in Python where keys are all nodes and values are all lists of connected nodes. So those zeros and ones within the outer dictionary is a list, and those values are values of that particular node. Memory efficient and easy to read. As we have seen in the previous example, it is memory efficient and also easy to read. The next one, let's see adjacency list in graph representation. So how does it look like? It looks like a graph here like this. It has a key and list of values. So this is also memory efficient, and this is the type of graph mostly used in our projects. So adjacency list is most widely used graph implementation. So let's see one example with adjacency list. For example, a flight map. So say flight graph we have. So a flight graph is a graph for flight map. We have different nodes with the key and its values. We can go through the relationship between key and value. So if say a flight DEL, a flight DEL, let's suppose it has two values which are its destinations. So from Bombay it has destination Delhi and Hyderabad, and Bangalore flight has destination Delhi and Chennai, and Hyderabad it has only one destination Bombay. and Chennai to Bangalore. So this is a graph adjacency list representation. So this is used in Python applications like travel apps, airline, route planners, logistics, networks, etc. And we have one more point to cover as part of Python graphs is graph traversal. There are two search techniques to use in order to do graph traversal in Python. Number one is breadth first search BFS and depth first search DFS. So these are the major types for traversing and searching for any node value from a graph. We will discuss about this further in another video. So let's summarize. What is a graph? Graph is nothing but node and edge as its connectivity to another node. And types are directed, undirected, weighted, unweighted. And we can represent two ways: adjacency matrix and adjacency list for its own use cases. And used in maps, networks, AI, recommendations, and as we have seen before, we can use it for social media as well. So that's about brief summary. So in next video, what we are going to cover for graphs, we will discuss about breadth first search and depth first search, cycle detection, and then we have Dijkstra's algorithm and graphs with Python class implementation. So that's all about graphs for today. If you find this video helpful, don't forget to like, comment, subscribe for more Python DSA tutorials. See you in the next video.